I think we can now start committing sacrilege in Niels Bohr's eyes by asking what lies underneath all of this. What's the source of the wave function? What's underneath the tip of the iceberg? All the questions that he said we shouldn't ask. In 1986, John Cramer published the seminal paper, The Transactional Interpretation of Quantum Mechanics, where he, inspired by Richard Feynman and John Wheeler's absorber theory, he proposed a similar handshake or a transaction in quantum mechanics. So let's define all of these terms, this lingo that I've just thrown around, in light of everything we just spoke about, the standard theory wave function, the measurement problem. What is the transactional interpretation?
Okay, well, the first place to start, I guess, is to kind of go back to that quantum state, the idea of a quantum state, which can be represented by a wave function, if we're considering position, that basically, when we think about wave equations, technically wave equations have two different kinds of solutions. They have a solution that is kind of the standard ordinary one that is future directed, where the time parameter increases, so to speak. But there's also a solution equally mathematically valid called an advanced solution. And this is a solution that seems to indicate a wave progressing to smaller temporal values. In other words, a past-directed wave. So, of course, it's a matter of interpretation, what these waves really are. Are they really propagating? How are they propagating? And so on. Now, from Cramer's development and the way Cramer first looked into this, he comes from the tradition that, again, that space-time is the container for everything real. So he just assumed, okay, these wave equations that describe these quantum waves have the future-directed, so-called retarded solutions, and they also have these past-directed advanced solutions. Well, I'm going to use both of them, and if I do that, and sort of the inspiration for this, again, was, as you mentioned, the Wheeler-Feynman so-called absorber theory of radiation. And he said, if I do that, it turns out that when I look at the amplitude of this interaction between this forward propagating wave and this backward propagating wave, it actually gives me this squaring of the Born rule. It actually just falls right out when I look at that interaction and I see, what is the amplitude. And as he thought of it, it was kind of a circuit where what he called an offer wave, which was the retarded future directed wave, goes to an absorber, and that the absorber responds with what he called a confirmation wave, which was this advanced solution, heading so-called, as he saw it, backward in time, back to the emitter, that this circuit just seems to give you the Born rule. So that's actually what got my attention when I thought, oh, look, there's actually some sort of theory that can derive or provide some sort of derivation for this Born rule, which was just an ad hoc rule historically. And so Cramer called this the transactional interpretation of quantum theory. And, he argued that it gave you a basis for measurement, which I think was correct for basically the non-relativistic form that he was considering at that time, that there's a validity to the idea that it's actually this absorber response that is giving you the mathematical apparatus that you need in order to see where the Born rule comes from. So that's what kind of grabbed me. And I thought, well, this is worth exploring. So, the more fundamental way to think about this perhaps is that rather than just an interpretation of the conventional theory, the so-called transactional interpretation is really a subtly different theory, because it works with a different theory of the way fields behave. So in other words, according to this theory, you don't simply have an emitter emitting what's called a retarded field, as people kind of tend to naturally think. But in fact, instead, radiation is a mutual process that involves the sort of ongoing participation of what we call absorbers, which are nothing more than, atoms that can that are in, say, a lower energy state, such that they can jump up to some higher energy state if they receive this energy, it's radiation. So it's basically the big difference here in this theory that it has this mutuality. So that kind of in a nutshell is, the transactional interpretation, which actually I think I'm going to start calling transactional theory, because it is a subtly different theory from the standard conventional theory. It does have a different model of the way the fields are behaving.
So just to check if I've understood this correctly, there are emitters and then there are absorbers, and we can talk about what emitters and absorbers are. And then there's this mutual, like you mentioned, this mutuality, this handshake or transaction between them. The emitter is emitting an alpha wave to the absorber. There could be multiple absorbers. They could take in that alpha wave, emit back. And I know I'm probably not using the right word when I say emit, but sending back, let's say, some form of a confirmation wave. You can have multiple of these possible transactions or handshakes. And in this entire range of spectrum of possible transactions, only one is actualized given by some probability. And that becomes the classical physical world that we see. Did I get that right?
That's pretty much it. Yeah. I mean, I would say that the emitters and absorbers are generating, they're each actually generating a time symmetric field.
Okay.
So that's kind of the basic field interaction, that they are each generating a time symmetric field that has both these components, the retarded and advanced components. But the portion that goes back and forth between them, from the standpoint of just looking at the kind of field that exists between those two, the emitter will be sending a retarded field that reaches the absorber, and then the emitter is receiving from the absorber this advanced field. And it's that overlap that creates this, that gives rise to this real energy. And as you said, you can have different possible, what I call incipient transactions. They are described by the Born rule. So you get the mathematical description of this field interaction precisely gives you all of that content that is in the so-called measurement transition that the standard theory just has to apply in an ad hoc way. So the standard theory has the mathematical apparatus that's going on in a so-called measurement, but it doesn't know where it came from. It can't provide any, justification for it.